Good afternoon, children.
Good afternoon, ma'am.
Good afternoon. Good afternoon, children.
Good afternoon, ma'am.
Good afternoon. All right. So, as I told you yesterday, we are starting a new chapter, circles. So, during the special classes, we'll be continuing with the chapter circles. The regular class tomorrow, we'll continue with linear equations, word problems. The special classes will continue with circles. You don't have to write anything, children. All the notes will be uploaded in the portal. I will also discuss the different features in the portal today. I don't know if all of you are aware of it. So at the end of the session, I'll also show you how the portal looks like now and what are the things you can see in your account there. So don't write
Ma'am, I
anything
have a
today.
doubt.
Yes.
Should I need to keep a separate note for circles and linear equation?
Yeah. I suggest that because it's easy to, like revise later. If you have more than 2-3 chapters in the same book, Mm, it's just the way you feel when you're revising. When you have separate books for, each chapter. So the volume. So supposing you want to revise only circles, so you'll have one small book in front of you. So it gives a good feeling when you're revising. When you have so
Oh,
many, when you have piles of books in front of you, and you're like looking into various books for circles. A little from one book, little from the other book, and when your table is full of textbooks and notebooks, it may cause stress in children. So
okay.
make your table. Yeah. So when you're studying, when you're revising, when you're preparing for an exam, you must make sure that you have very, very few material in front of you. So
Okay, ma'am.
then when you have just your, one notebook on circles, your mind is like, that's it. Just this book and I'm ready for the exam. So it can keep you motivated.
Okay.
Yeah. So a circle is a collection of all points in a plane which are at a fixed distance from a fixed point. So the fixed point is called the center of the circle. The fixed point is called the center of the circle. And the fixed distance is called the radius of the circle. It's called the radius of the circle. So you consider a plane surface like this. Okay. You consider a plane surface like this. Now there are so many points on a plane surface. There's a collection of infinitely many points. Okay. Many points. So the collection of all those points in a plane. Okay. So see here, you can see what I've done. Okay. So the collection of all these points. There are many other points. When you consider a plane surface, you consider a limited plane surface, like a blackboard or the top of your table. Consider a limited plane surface. So on that plane surface, there are infinitely many points. Now, of those infinitely many points, the collection of only those points which are at a fixed distance from a fixed point is called a circle. So you can see here, I've taken a limited plane surface like this, and I cannot show you all the infinitely many points, right? So you can see the points I've marked here, and the collection of all these points on the plane, which are at a fixed distance from this point. So the distance, supposing I call this point O, and this point A, this point B, there are many points, this point C, this point D, this point E, this point F. Okay, so this point X, this point Y, this point Z. So now, why have we selected these points A, B, C, D, E, F, X, Y, Z? Why? Because the distance OA is equal to the distance OB is equal to the distance OC is equal to the distance OD is equal to the distance OE is equal to the distance OF is equal to the distance OX, OY, OZ. So a circle is a collection of all points in a plane which are at a fixed distance. All those points must be at a fixed distance from a fixed point. This fixed point is called the center of the circle, and the fixed distance is called the radius of the circle. All of us understand that?
Yes, ma'am.
Okay. So now let's consider a point lying inside the circle. Another circle. See, I'm not defining the terms radius, diameter, circumference, arc, sector. See, we've seen all this in standard 9. We'll recall all this if needed. Whenever we come across a situation like that in a question, we'll recall. So now we'll not spend time recalling what a sector is, a sector or arc, segment and all that. I'm not doing now. Okay. Okay, now next we'll consider 3 points A, B, and C. Point A lies inside the circle. Okay, point A lies inside the circle. Point B, same circle. Okay, same circle. Point B lies. Okay, let me mark it here itself. Let me mark it on the same circle itself. Okay, so point A lies inside the circle. Point B lies on the circle. Point C lies outside the circle. See, we know that a circle divides the plane surface on which it lies into 3 parts. So if this is the plane surface on which the circle lies, the circle divides the plane surface on which it lies into 3 parts. Okay, so the collection of all the points inside the circle, which is called the interior of the circle, interior of the circle. The collection of all the points on the circle, the collection. See, a plane has a collection of infinitely many points on it. So we are looking at the 3 parts or the 3 regions with respect to the points. Okay, so the collection of all the points lying inside the circle forms the interior of the circle. So that is one region. Interior of the circle. I said the circle divides the plane on which it lies into 3 distinct regions. Now we are going to see the 3 distinct regions with respect to the points on the plane surface. Now, the collection of all the points lying inside the circle, the points lying inside the circle also lies on that plane surface. The points lying inside the circle also lie on the plane surface. Okay, so the collection of all the points lying inside the circle form the interior of the circle. So this is one region. Then the collection of all the points that lie on the circle is the circle itself. See, actually, only this is the circle. If you want to include this, it's called, this full thing is called the circular region. When we say circle, it is only this ring. This is a circle. This is not, if you're talking about this whole thing, you know, if you have a circle made from cardboard, that's a circular region. It's not a circle actually, but we use a meaning circle also represents circular region according to the situation. Now we don't say find the area of the circular region. Okay, so you're given a circle, radius 7 centimeters, and the question is find the area of the circle. Find the area of the circle, but circle is only this portion. Only this one is the circle. So circle actually has length, which is the perimeter. You're finding the area of the circular region, but the question will be find the area of the circle. So I'm trying to say that circular region, they are 2 different things. By definition, they are 2 different things. But then in practical situations, they are used, meaning we never use circle or region at all. We just say circle. Whether it is circle or circular region, we say circle only for both. So this is the interior of the circle. The points lying on the circle is called the circle, is the circle itself. That is how the circle is defined. The circle is a collection of all these points. So the points lying on the circle is a circle itself. It's a circle itself. And the collection of all the points lying outside the circle form the exterior of the circle. Exterior of the circle. You must understand that the points lying inside the circle, that is the interior of the circle, on the circle, exterior or outside of the circle, all of them lie on the plane surface. All of them lie on the plane surface. So the plane surface, or the collection of all the points on the plane surface, is divided into three. The collection of all the points that lie on the plane surface is divided into three parts because of the circle. Because of the circle. So one is the interior of the circle, which is the collection of all the points lying inside the circle. Then the second region is the circle itself. The second region is the circle itself. The collection of all the points lying on the circle is the circle itself. And the third region is the collection of all the points lying outside the circle, which forms the exterior of the circle. Okay, so now we have considered 3 points A, B, C. One, that is the point A, which lies in the interior of the circle, the point B, which lies on the circle, and the point C, which lies outside the circle. So in the three different regions, we have taken 1 point each. We have taken a point A, which lies in the interior of the circle. We have taken a point B, which lies on the circle, and a point C, which lies in the exterior of the circle. Now let's join O to A, O to B, and O to C. So we know that OB is R. OB is equal to R. We know that OB is equal to the radius of the circle. So now OA, the length of the line segment OA will be less than the radius, and the length of the line segment OB is equal to the radius. The length of the line segment OC is greater than the radius. The length of the line segment, when you join OA, it's a line segment OA. OA is now a line segment. The length of the line segment OA will be less than the radius of the circle. Supposing the radius of the circle is 10 centimeters, OA cannot be 10. It will be less than 10. OA cannot be 10. It cannot be 10, and it cannot be more than 10. It will be less than 10. So the length of the line segment OA will definitely be less than the radius. Then the length of the line segment OB will be equal to the radius of the circle. So the radius of the circle is 10, then OB is 10. OB cannot be less than 10, OB cannot be more than 10. The length of the line segment OB will be equal to the radius of the circle. Then the length of the line segment OC. The length of the line segment OC will be more than the radius of the circle. So the radius of the circle is 10 centimeters. OC cannot be less than 10. OC cannot be less than 10. OC cannot be equal to 10. OC has to be more than 10. So this might be a simple result, but it's very important because we use it in certain places for proofs. Simple to understand, but very important to derive very important proofs. So OA will be less than the radius. OB is equal to the radius. OC is greater than the radius. Interior of the circle, circle itself, exterior of the circle. Then about 3 points lying, 3 points, one lying inside the circle, one on the circle, one outside the circle, and how they are related to the radius. The relationship between the points, one lying inside the circle, one on the circle, one outside the circle. The relationship between the line segments you get by joining these points to the center and the radius. So far, fine, children?
Yes, ma'am.
All of you? Any questions?
Yes, ma'am. No doubts, ma'am.
Okay.
No doubts, ma'am.
All right. So next is the relationship of the relationship between a circle and a line. Okay. Relationship. Okay. So the relationship between a circle and a line, not a line segment, and a line with respect to the position of the line. With respect to the position of the line. So now case one, there's a circle and there's a line. Now, on the circle, there are infinitely many points. On the line also, there are infinitely many points. But there is no point common to the circle and the line. So here there is no relationship between the circle and the line. There is a circle, there is a line, but there is no relationship between the circle and the line. There is no relationship between the circle and the line. Because the circle has infinitely many points in it. A line also has infinitely many points in it. But there is no point common to the circle and the line. Hence, there is no relationship between the circle and the line. So here is a circle and a line. As we understood, the circle has infinitely many points on it. The line also has infinitely many points on it. But there is only one point which is common to the circle and the line. See, diagrammatically, you will feel that there are so many. You might count like 1, 2, 3, 4, 5 points are there common. It's not like that by construction. Okay, it's not like that. So when you draw a circle and a line, see by hand also maybe you cannot. You might feel like 2 points are touching. In reality, no. Okay, so you can draw a circle. In reality, you can draw a circle and a line which have only one point in common. Maybe I'm not able to draw or you're not able to draw, but there exists a circle and a line which can have exactly one point in common. Let me put it that way. Okay. Yeah. So this is a case where we have a circle and a line. Circle has infinitely many points on it. Line also has infinitely many points on it. And there is only one point that is common between the circle and the line. This line has a relationship with the circle. This line has a relationship with the circle because there is one point common between the circle and the line. Only one point is common. Circle has many points, line has many points. Only one point P lies on the circle and lies on the line. There is only one point P that lies on the circle and on the line. Does P lie on the circle? Yes. Does P lie on the line? Yes. So there's only this point P which is common to the circle and the line. And this line is called the tangent to the circle. This line is called the tangent to the circle. A tangent is a line. It's not a line segment. A tangent is a line that touches the circle at exactly one point. A tangent is a line that touches a circle at exactly one point. Now, if you take any other point on this tangent, supposing you take this point A, then this PA is called the tangent segment, like how you say line segment. See, this is a line. This is a line. Now, if you mark P and Q here, this is the line L. This is a line L. If you mark a point P and Q here, if you mark a point P here and Q here, then PQ is called a line segment. It's called a line segment, meaning it's a part of a line. Line segment meaning it's a portion of the line. Line is Imaginary, no? Line is imaginary. It extends indefinitely. So you can only imagine that. Oh yeah, line is like this. So a line extends indefinitely on both the sides. So when you mark 2 points on the line like this P and Q, now PQ is a line segment, meaning it's a part of that line. Similarly, a tangent is a line. Now, when you take 2 points on the tangent, so one is the point P and another point A like this, then PA is called the tangent segment. Tangent segment, because it's a part of the tangent. Tangent is a line. Children, I'm just getting a call. Sorry. Please hold on. Yeah. Yeah, so I was telling you that PA is called the tangent segment because it's a part of the tangent and tangent is a line. Okay, so that's about case 2, where the circle and the tangent have, where the circle and the line have exactly 1 point in common. Case 3 is circle, line. So the line intersects the circle here, say at A, intersects the circle here at B. I told you circle means only this ring. Now don't say, yeah, these points are also there, which is common to the circle and the line. No, when we say circle, we are talking only about the boundary. When we say circle, we are talking only about the boundary. Now this one is the interior of the circle. Now you might think that, see, now this point lies inside the circle and it is also on the line. So this is also common. No, when we say circle, we are talking about only this ring, only this ring. Okay, so now here you can see a line that intersects the circle at 2 distinct points, A and B. A and B. This line intersects the circle at 2 distinct points, A and B. So again, the circle has infinitely many points on it. The line also has infinitely many points on it. But of these infinitely many points, there are 2 points common to the circle and the line. There are only 2 points common to the circle and the line. Point A lies on the circle and lies on the line. Point B lies on the circle and on the line. So A and B are the points common to the circle and the line. This line has a relationship with the circle, and this line is called the secant to the circle. It's called the secant to the circle. Secant. Secant. Okay, this line is called the secant. Secant to the circle. So AB is a secant, or you can call this L, and L is a secant. L is a secant to the circle because it intersects the circle at 2 distinct points. It intersects the circle at 2 distinct points. Now, this is all, these are the cases we can have. Either there is no point in common between a circle and a line, or there is exactly 1 point common between a circle and a line, or there's exactly 2 points common between a circle and a line. You cannot draw a line. You cannot draw a line where the circle and the line have 3 points in common or more than 2, anything more than 2. 3, 4, 5, 6, 7. No. There can be a circle and a line with no point in common. There can be a circle and a line with exactly 1 point in common. There can be a circle and a line with 2 points, exactly 2 points in common. More than this is not possible. You can draw a circle and a line, but you cannot draw a circle and a line such that they have 3 points in common, or such that they have 4 points in common, such that they have 5 points in common. You cannot draw. They does not exist. So these are the only 3 cases. So case 1, no relationship. Case 2, it's a tangent. The line is a tangent. Case 3, the line is a secant. Is it fine, children?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yeah. And you can draw many tangents. You can draw
Yes,
to a
ma'am.
circle, no, to a given, yeah. To a given circle, you can draw many tangents. You can draw, many secants. Sorry. Okay, you can draw many secants. You can draw many secants. Okay, but at a given point, now at a given point P, supposing you take, let me take the next slide. Now circle, okay. Now this is the point P. Now, if I ask you to draw a line passing through P, there's only one line that passes through P. The other lines will intersect. See, okay, let me go down again to, I think 6th, 7th or 8th standard. We know that there are infinitely many lines passing through a given point. We know that there are infinitely many lines passing through a given point. Infinitely many lines passing through a given point. So we have this point P. So we know that there are infinitely many points passing through the point P. Infinitely many lines passing through, passing this through this point P. Of these infinitely many points, there is only one line which can act as a tangent to the circle. Take a point P on the circle. We know that there are infinitely many points. We know that there are infinitely many lines passing through a given point. So through the point P, we can draw infinitely many lines. 1 minute, children. Yeah, so circle, a point P on the circle. And we know that through a point, we can draw infinitely many lines. So we try to draw, we cannot draw infinitely many lines. So we try to draw a few lines passing through this point P. Of these lines, only one line can act as a tangent to the circle. That means through a given point, there's only one line that can be the tangent to the circle. That means we can construct. If they give you a point, and ask you to draw a tangent to the circle, tangent at that point, you can construct that. That's unique. All of us will get the same thing. Supposing I see, like, I draw a circle and I mark a point. Okay, so like I draw a circle and I mark a point, say A here on it. Okay, and I make some 10 Xerox copies. And I hand out the papers to you and I ask you to construct a tangent through this point P. All of you will get the same line. Because I've given the same circle, no? So circle, point A on it, I've made 10 copies and given it to 10 of you. And all of you construct the tangent. All of you will get the same line. It's unique. There's only one line. And that line only can be a tangent to the circle, though there are infinitely many lines passing through a given point. The other lines will be secants to the circle. What about the other lines? The other lines are all secants because they intersect the circle at 2 distinct points. See here, this line here and here it intersects. This line, if you produce it here and here it intersects. All the other lines will be, only one will be a tangent. The others are all secants. Only one line will be a tangent. All the others will be secants. They are related. All the other lines will be related to the circle. All the other lines are related to the circle. One of it is a tangent. The rest are all secants. Is that fine, children?
Yes,
Okay,
ma'am.
all of you? Okay. Now, another theory is that when you have a circle, and a tangent. Okay, and a tangent, just excuse me, this is common. Okay, so now here we can see the tangent L, and P is called the point of contact. The point where the tangent touches the circle, or that point which is common to the circle and the tangent, is called the point of contact. Point of contact is the point which is common to the circle and the tangent, or the point where the tangent touches the circle is called the point of contact. Now you can see OP is the radius, P is the point of contact, L is the tangent. Now you can draw only one other tangent which can be parallel to the given one. That is here, see here. You can draw a tangent like this. Okay, so this line is L dash, and say this one is P dash. This point is P dash. Okay, so L and L dash are parallel tangents. P and P dash will be the ends of a diameter. Ends of the diameter. This is a theory. To a given tangent L, you can draw only one tangent which can be parallel to the given one. You cannot draw any more tangent. If there is one tangent L, there is another tangent L dash which is parallel to L. That's all. But if you're given a secant, you can draw many parallel secants. To a given secant, you can draw many parallel secants. But to a given tangent, you can draw only one other line which is parallel to the given tangent. And you will see that the points of contact P and P dash will be the ends of a diameter. The points of contact P and P dash will be the ends of a diameter. I'll draw the same thing again. Circle, circle, center, point P, tangent through P. Tangent through P. This tangent is called L. P is the point of contact. Now, the question is, we need to draw a line. We need to draw a line which is the tangent. Okay, so we need to draw a tangent which is parallel to the given tangent L. We need to draw a tangent to this circle, which is parallel to this tangent L. It's possible, you can do it. Tangent, no, so it should touch the circle at only one point. You can do it. So here you have L dash. L dash is a tangent that is parallel to the tangent L. Now P dash is the point of contact. P dash is the point of contact. When you join P dash and P, you will see that they pass through the center. I'm just telling the same thing in a different way. I'm not saying something else. What I told earlier, I'm putting that in a different way, that's all. So when you join the points P dash and P, you will see that you won't take efforts to make it go through the center. It will go through the center. You don't have to adjust your scale and all that and make sure that it passes through the center. It will easily pass through the center. The line segment P dash P. The line segment P dash P will pass through O. So clearly, P dash P is the diameter to the circle. Is the diameter to the circle. So this is another thing you'll have to remember. Given a tangent, you can draw only one other tangent which can be parallel to the given tangent. All right. Is this clear, children? No, this will prove. Now your question will be like, this is fine, but how do we prove it? Yeah, we have the proof. I'm just sharing all that you need as a part of the introduction. Now, is this believable or unbelievable, children? Do anyone here feels like it's not clear, or like it's not possible? I can try to draw more than it's understood, no? Even without a proof. You all agree with that, right?
Yes, ma'am.
Yes, ma'am.
Yes,
It's
ma'am.
believable.
Yes,
It's
ma'am.
believable. Yeah, though we want a proof, it's believable. Yeah, that's what it is. Okay, children. Okay, so this is what it is. So L and L is a tangent. L is a, so how do so that when it comes to certain chapters in mathematics, there's a language for that chapter. So like your physics and chemistry, you have keywords. You cannot, though it is written in English, you have some keywords, right? And specific to physics, specific to chemistry, biology. You'll have to use those words. And that makes the subject not English, but physics. What makes we write physics in English? But when you read it, it is physics and it's not English. Because the contents, the keywords make it physics and not English. Similarly, though this is English, here it is not English and math. And in the chapter circles, you use certain keywords which make it the chapter circles. So how do you explain the situation? Okay, L is a tangent to the circle with center O at P. L is a tangent to the circle. You can say just circle also. So L is a tangent to the circle with center O at P. L dash is a tangent. L dash is a tangent to the circle with center O at P dash. L dash is a tangent to the circle with center O at P dash. P and P dash are called the points of contact, not point of contacts. Don't say contacts. Points, plural, points. Points of contact. Contact does not have plural form. Don't say contacts. Contact is wrong. Points of contact. Okay, so P and P dash are the points of contact. L is parallel to L dash. L is parallel to L dash. P dash P is the diameter. When you join P dash P, you will see that it's a diameter. All right, children? Okay.
Yes, ma'am.
Very good. Yeah, so about secants, when you draw secant, to this secant, you can draw infinitely many parallel secants. To the given secant, you can draw infinitely many parallel secants. Yeah, you know that. So given one secant, given a secant to the circle, infinitely many parallel secants can be drawn. Parallel secants can be drawn. Given a secant to the circle, given one secant to the circle, you can draw infinitely many parallel secants. To that secant, you can draw many secants which are parallel to the given one. But tangent, only one you can draw. To another tangent, you can draw, okay, to a different tangent. Now, supposing you take a tangent here, you can draw a tangent like this parallel to the given one. If you take this tangent, you can draw a tangent here parallel to this one. So like that. There are many. To a circle also, there are so many tangents. You can draw so many tangents to the circle at different points. If you take one point A, there's only one tangent passing through A. At this point A, there's only one tangent passing through it. But the circle has many other tangents. You can draw many tangents to the circle at different points. And each tangent will have another tangent parallel to it. Each tangent will have a different tangent parallel to it. Okay, so that is about, the tangents and secants. If you can draw parallel tangents, parallel secants, that's about it. Yeah. Yeah, so next is also about, a part of 9th standard which was deleted. So we need to do that before we understand the theorem. Okay. Now, so this is a part of 9th, this is 9th standard, children, but this part was omitted for you. So let's do it now. Line. Okay, line L. Line L. And there's a point, say A, lying outside the line L. There's a point A lying outside the line L. Now, we are trying to figure out the shortest distance. Just imagine you are standing here at A. You are standing at A, and there is a line like this L. So maybe you can imagine you're on the beach, a seashore. Okay, so you're standing at a particular point A, and there's a line marked on the shore. On the shore, there's a line like this called L. You need to run from this point and come and touch this, line L. Okay, you should just run from here and touch this line L. And the question is, which is the shortest distance? If you are smart, see, you want to be smart, so you will use the shortest distance. Okay, you will use the shortest distance. So now we are trying to find out the shortest distance from this point A to the line L. We'll see the situation again. The situation is, why seashore? You're standing in a playground. Playground. You are standing at point A in the playground. Your PT master, he's drawn a line L. And he wants, it's a line. It's a line, so it stretches maybe end to end in your playground. So he makes every student stand here at A. Okay, one by one. They'll take turns and stand at A. From there, the task he gives you is you'll have to come and touch this line. Touch the line. That's all. So obviously you will use the shortest route to come to L. He will not note the time. He will not see the duration in which you come and reach L, because you may be fast at running, slow. So he's not judging that. He's only going to judge the distance you cover to touch L. He's only going to judge the distance you're covering. It's okay if you're slow, you're fast. It's okay. He will not see how long you take to reach the line L. He will only check the distance you have covered to touch the line L. What distance have you covered? What distance have you covered to touch the line L? He will not see how fast you came or how slow you were. So now now you are at this point A. So what you do? You come straight, bang. You just walk bang straight, and you touch the line L like this. Some of your friends, they want to do it differently. Your friends want to do it differently. They don't want to copy you. They want to be unique. So one friend walks like this, and she says, even I touched the line L. Now we'll take only 2 friends. Okay, we'll only take 2 friends. So you were at A, and you walked straight across to touch the line L. And so the distance you have covered is AB. The distance you have covered is AB. Now your friend, she does not, she or he, I'll say she only because he is different. She, okay, so we girls are more egoistic, than boys. Boys don't mind. They would, if it is another boy, he would probably take the same path. So there's another girl, and she doesn't want to take the same path her friend has taken. So she says, I'm going to take a different route, and she walks along like this. And she says, sir, I have touched the line L, and the distance or the path she has walked along is AC. AC. So your friend started from A and she walked along the path AC and she touched the line L. You also started from A and you walk along AB and you touch the line, the same line L. Okay. Now the route you have taken, is AB. The route your friend has taken is AC. Just a second, children. I'm just coming. Yeah, thank you, children. So it so happens that you have taken the perpendicular distance because you walked straight across, to reach the line L. So you have taken the perpendicular distance. So like your path and the line are perpendicular to each other. You're very smart, no? So you have taken the perpendicular distance. You go straight, bang straight and touch the line. So you have taken the perpendicular distance, meaning the path, your route AB and the line L are perpendicular to each other. Your path AB and the line, they are perpendicular to each other. Now we know that now this one forms a right triangle. No, the path you have taken AB, the path your friend has taken AC and BC. These three line segments, they form a triangle. So ABC is a triangle. ABC is a right triangle. ABC is a right triangle. And we know that the hypotenuse is the longest side in a right triangle. So AC is definitely, so when you compare the sides, AC is greater than AB. AC is also greater than BC. Now we are not interested in BC because we are only comparing the paths taken by the two friends. We are not bothered about BC, whether BC, the AC is the longest side. That is enough for us. AC is the longest side. So we are not concerned about BC. BC is not a part of our discussion at all. Whatever is, see, we know that AC is the longest side. Okay. And we are comparing the two paths, AC and AB. We are only comparing the paths taken by one girl AC and yourself AB. So now AC is the greatest, AC is the longest side. AC is the longest side. Okay. Why AC is the longest side? Because it's opposite the right angle. So it's the longest side. Now AB is definitely less than AC because AC is the longest side. Then AB is less than AC. In the triangle ABC, since AB is the longest side, this is the longest side. This is shorter than AC. This is shorter than AC. This is shorter than AC. So clearly you have taken the shortest distance. Shortest when compared to your friend. You have taken the shortest distance when compared to your friend. So with respect to that friend, your distance is shorter. So you're happy that you made a good decision. Now there's another friend, another girl, okay? Another girl. So she also doesn't want to copy any of you. So she walks like this. She walks like this. Okay, so she walks along the path AD. She walks along the path AD and she touches the line L. Now again ABD, again ABD is a right triangle. ABD is a right triangle and AD is the longest side. So again you win. Your side is, your distance is shorter. Now ADB is a different right triangle. Is a different right triangle. Okay. However, since AD is the longest side, your root AB will be less than AD. So still you win. You have taken the shortest side route. You have taken the shortest route. Okay, another friend. She doesn't want to come this side at all. So she says, let me walk like this. Let me walk like this. And she touches the line L at E. Here also it's 90 degrees only. So again, ABE is a right triangle. ABE is a right triangle. Yourself taken the path AB. Your friend has taken the path AE. Again, AE is the hypotenuse. AE is the hypotenuse. So AE is definitely greater than your path AB. That means your path AB is less than AE. So you win. You win because you have smartly taken the shortest distance. The others don't copy you, but all their distances are longer than yours. See, I'm not saying that AC is equal to AD. They are two different routes. They'll have different lengths. However, yours is the shortest. That's all it is. I'm not saying AC is equal to AD. I'm not saying AE is equal to AD. They're all different routes. All of them are different. But when you compare yourself with your route with the other routes, your route is the shortest. And the shortest route is the perpendicular distance. The shortest, you did not know that you're going to take that. You just walked straight to touch the line L. And so your path makes a right angle with that line L. And that happens to be the shortest distance. That happens to be the shortest distance. So the others, they don't copy you. They want it to be unique. So they walk along AD, AC, AE. But you're able to compare yourself with everybody. You're able to compare yourself with everybody because yeah, you are able to compare yourself with everybody because see, how do you compare yourself with AC? Because ABC is a right triangle. How do you compare yourself with AC? So how do you compare yourself with AC? So you are your path is AB and your friend's path is AC. So you can compare using the right triangle ABC. ABC, wherein your friend's path AC is the hypotenuse. In the triangle, don't see this line now. See only the triangle ABC. In the triangle ABC, your friend's path is AC. Path, I'm saying the route. Path, route. Okay, so your friend's path is AC. PATH, path, the route your friend has taken. Okay, is AC. Yours is AB. Now you know that her route is bigger than yours because that's the hypotenuse. That's the longest side. So her route is longer than yours. Then how do you compare yourself with AD? How do you compare your route with your friend's route AD? Again, because ABD is a right triangle. And your friend's route AD, that's the hypotenuse. So it's the longest side. So that distance is more than yours. The same thing with triangle ABE. Another friend of yours has taken the route AE. And that is the hypotenuse in the right triangle ABE. So that's longer than your route AB. So like this, nobody copies you. Okay, nobody wants to copy anybody. Everybody takes a different route. So you are the winner because you have taken the shortest distance. When you compare, when your master compares the other routes with your routes, yours is the shortest because you have taken the perpendicular distance. So the conclusion is, to a given point, okay, I'll write the result itself. The perpendicular distance is the shortest distance, between a point lying So the perpendicular distance is the shortest distance between a line L and a point A lying outside the line L. So from a point A, if you want to reach the line L, the perpendicular distance is the shortest distance. The perpendicular distance is the shortest distance. So this is the shortest distance. Because we know that we can touch the line L using many routes, but the perpendicular distance is the shortest route. All right. Just a second, children. Yeah, this is a very important. It's a very simple theorem, but a very important theorem. So the statement goes like this: the tangent at any point of a circle, the tangent at any point of a circle is perpendicular to the radius through the point of contact. Okay, so let's consider a circle. I've shared a different presentation, children. It's visible, right? Can you see the
Yes,
theorem I'm reading? Yeah. So we have a circle. Okay, and let's take a circle with center O, and let's take a point P on the circle, and we have a tangent through this point P. We have a tangent through this point P. Okay. So the tangent at any point of a circle. Now the point we have taken on the circle is P. And so we have a tangent through P. L is the tangent through P. The tangent at any point of a circle is perpendicular. The tangent is perpendicular to what? To the radius. The tangent is perpendicular to the radius through the point of contact. Because radius means there are so many radii. In a circle, you can draw circle, center, radius. There are so many you can draw. It's not one, no, many. So to which radius? To which radius? The radius through the point of contact. Let's first memorize the statement. The tangent at any point of a circle is perpendicular to the radius. To which radius? There are so many. To which radius? To the radius through the point of contact. The tangent at any point of a circle. Any point of the circle, you can draw a tangent. So the tangent at any point of a circle is perpendicular to the radius. If you say simply to the radius, which radius? To the radius through the point of contact. Okay, so which is the radius through the point of contact? This is the point of contact. So this is the radius through the point of contact. This is the radius through the point of contact. Circle, center O, point P, tangent L, P is the point of contact, and PO is the radius through the point of contact. So the statement is the tangent at any point of a circle is perpendicular to the radius through the point of contact. So that's what, so we have to prove that the radius and the tangent are perpendicular to each other. That's what we have to prove. We'll have to prove that this is 90 degrees. We'll have to prove that this is 90 degrees. We'll have to prove that this is 90 degrees. Is the statement understood, children?
Yes, ma'am.
Okay. Since I started at 12:30, I'll just wind up at 1:45. Okay, it's touching, children, okay? It's touching here at me. I want to draw neatly, but this pen tablet, no, the surface is so smooth. I'm not getting my hands on it. Yeah, so the thing is, we have to prove that. To prove that, let me take a point, okay? Let me take a point A. Okay, so to prove that angle APO is equal to 90 degrees. This is what we'll have to prove. We'll have to prove that angle APO or OPA or APO is 90 degrees. This is what we'll have to prove. Okay. So now you can see that situation here, no? That the situation which we just discussed. Can you see the line L, which is a tangent? And can you see the center of the circle O, which is like a point line outside the line? This situation, oh, that's in a different presentation. Okay. So the situation which we just discussed, a line and a point line outside the line L, the shortest distance is the perpendicular distance. The shortest distance is the perpendicular distance. So that is what we have. That is what we use here to get the result. To prove that angle APO is equal to 90 degrees, we use that result. What is that? The perpendicular distance is the shortest distance. The perpendicular distance is the shortest distance between a line L or between a line and a point lying outside the line. If there's a line and a point lying outside the line, the perpendicular distance is the shortest route. So you can see that here, you can see a line, you can see point O outside the line L. So you have to prove that to get this is 90 degrees. See, sometimes you cannot prove it's 90 straight away. You'll have to prove something else, and through that you will get 90 degrees. So here, instead of proving 90 straight away, prove that OP is the shortest route. Prove that OP is the shortest route from O to L. Prove that OP is the shortest route from O to L. L is a line. The tangent L is a line. O is a point. Prove that OP is the shortest route from O to L. And we know that the shortest distance is the perpendicular distance. We know that the shortest distance is the perpendicular distance. So instead of proving angle APO is 90 degrees straight away, we'll prove that OP is the shortest distance. So if you prove OP is the shortest distance, it's a perpendicular distance. So that means you'll have to compare OP with other line segments. You'll have to compare. How will you say that OP is the shortest route? You'll have to compare OP with other line segments. So now look at the various points lying on the line L. Now, what's the definition of a tangent? A tangent is a line which touches the circle at exactly one point. That means all the other points on the tangent lie outside the line. Outside the circle. The tangent has many points on it. There is no point on the tangent which lies inside the circle. The tangent has many points on it. There's only one point on the tangent which touches the circle. All the other points on the tangent lie outside the circle. There's no point on the tangent that lies inside the circle. See, if you take any point on the tangent, if you take other than P, you take this point, lies outside the circle. This point lies outside the circle. This point lies outside the circle. Now, any point to take on the tangent, they'll all lie outside the circle. Only P lies on the circle. There is no point on the tangent that lies inside the circle. So that is a definition of a tangent. All the points on the tangent will lie outside the circle. Only this point P lies on the circle. So now when you compare, you can take like 2 points A and B. When you compare OP and OA, or when you compare OP and OB, you have to see, our idea is to we have to prove that APO is 90 degrees, but we're not hitting that straight. We are getting it in a different way. We are trying to prove that OP is the shortest distance. Once you prove the shortest distance, automatically it becomes a perpendicular distance. So 90 degrees. So we are trying to show that OP is the shortest distance. So we'll compare OP with other routes. Like how you compared your distance, like how your PT master compared your route with your friend's routes. So like that here we compare OP with OA and OB. So OP with OA, again OP and OA. Now you cannot say that OA is the hypotenuse, children, because we don't have right angle at all. Now don't say OA is the hypotenuse. No. OA is not the hypotenuse because we don't know if it is 90 degrees. So here what you should use is A is a point that lies outside the circle, and we know that OA is greater than R. OA is greater than R, but whereas OP is equal to R. So clearly OP is less than OA. 1 second, children. Yeah, children. So we know that, A is a point that lies outside the circle. A is a point that lies outside the circle. So we know that OA, the length of the line segment OA is greater than R. But what is OP? It is equal to R. So clearly OP is less than OA. Same thing with OB. OB lies outside the circle. So OB, the length of OB will be greater than the radius. But what about the length of OP? It is equal to the radius. So here also OP is less than OB. So like this, if you compare the line segment OP with any other line segment, OP will be the shortest line segment. So that means this is the shortest distance from O to the line L. OP is the shortest distance from the point O to the tangent L. That is from the center of the circle to the tangent L. And we know that the shortest distance between a point and a line is the perpendicular distance. So therefore, angle APO is equal to 90 degrees.
Ma'am?
Yes.
Ma'am, I have a doubt. OB is equal to OA, ma'am?
No, that you cannot say. They'll be different. They need not be equal. They'll be different. OB need not be equal to OA.
Yes.
Now see the radius, supposing it is 5 centimeters, OB will not be 5 or less than 5. It will be like 6. OA will be like 7. And then this one, it will be more only. It will be like 11. As you come closer, it will be less. Now this might be like something like 5 point. I'm just writing for example. As it goes away, it will be longer. So this is the statement, and this result is very, very important. The tangent at any point of a circle is perpendicular to the radius through the point of contact. You cannot just say radius through the point of contact. Tangent at any point of the circle. So the tangent at any point of the circle is perpendicular to the radius through the point of contact. Remember this theorem, the statement also you should remember. Proof you have to memorize. You need to understand and memorize the proof. How many of you are in the habit of memorizing after understanding? Wherever you can memorize, I'm asking. I'm not saying in general, how many of you memorize whatever you understand? Not in maths, in general, I'm asking. Raise your hands. Padamita, Rakshita, Shri Krishmi. Madhumita, Rakshita, Shri Krishmi, Tanishka, Shri Ranjan. Okay, so the others, Danya, you don't memorize? Danya?
Ma'am, most probably after understanding, I will try to write in my own words.
What about biology?
Mostly in biology, I try to write in own words, ma'am. For physics, I memorize, and for maths theorems, I memorize.
Okay, Prajit?
Sometimes I try to memorize, ma'am.
But it's difficult, huh? For children today, it's difficult to memorize, right?
Not that much, like, yeah, somewhat, yeah.
Raghavi? Ritika?
No, ma'am, I memorize somewhat.
Ritika? Dileeban?
Ma'am, I don't memorize.
You don't,
I'll
huh?
understand first, ma'am.
Okay. Ranjan? Ma, I won't
Ma'am, I will.
memorize. Maths you don't
Words.
memorize. Fine. Maths you cannot, yeah, not maths. I'm like, in general, theory where you can memorize, where it's possible to memorize, do you memorize? I'm not saying math answers if you will memorize. Theory only. The theory part in maths. Okay, Ritika says yeah. No, children, it is very important. Where certain areas, where any subject, wherever theory is involved, even in practical subjects, there are theory, right? So it is important. Memorizing is also a skill. It's not easy to memorize. I don't know, this generation, you've been taught in school to write in your own words, understand and write in your own words. But okay, that again is a big topic to talk about. Why you should memorize, but just take it from me that memorizing is a very important skill. Memorizing, you need to understand and then memorize. Biology, especially, you have to memorize, and if you want to crack, exams, entrance exams and all that, you need to master the art of memorizing. Because memorizing saves time, meaning everything is just ready. You have a library in your mind. So it's just going to give you the answers like that, and you're going to be so fast in answering. Unlike writing in your own words, where you'll have to little bit think and write. See, how do you memorize? You understand. You understand 100%. You understand, and then you memorize so that you write the theory in less time in exam. You just write it. You finish it so fast. As against when you have to think and write, you might sometimes miss on some points. Then the language, will not be technical. The language will not be technical. It will be like more like English. It has to be very technical. See, you don't know. Tomorrow you might be a professor. You might do your medicine, but you might become a teaching staff. Not all of us like to practice. So you might do your engineering, but you might land up teaching. You might land up becoming a professor in an engineering. Or you don't know what life has in store for you. You might have decided that I'm going to do this and that, but your destiny is defined and you're going to be what is destined for you. So every subject has a technical thing involved in it, and you need to, use the technical terms in your exams. And for that, according to me, you have to memorize. Memorizing saves time in the exam. You can write answers very, you can write your answers very well and fast. And for entrance exams, you have to memorize. Now for NEET, it's more theory. You don't have math. Physics, chemistry, apart from the sums, the rest is theory. So when you memorize, you can recall faster. The libraries, the book is in your mind. So you can recall answers faster and finish it in less time. So I would suggest master the art of memorizing. Understand, and also wherever possible, you should memorize. It's not easy to memorize. Memorizing is looked down upon by students today. I don't memorize. So we take pride in saying that, we take pride in saying, like, there are people I have seen, my relatives settled abroad, and they are proud to say that their, children do not know to talk Tamil. No, our children don't know to talk Tamil. So yeah, that's how they look at a language. So it's actually a pride, to learn many languages. It's nice to say that you know English, so I know I can talk English. See, whether I'm very good at it, that's a different thing. But you can talk to the extent the other person understands at least. So language is important for communication. So when suppose I know Tamil and you know only Hindi. Now we cannot talk to each other, but maybe we would bond very well. Maybe, we bond very well. You're a good human being and I'm a good human being, and maybe we could bond very well, but then we don't have that language in common to communicate. So language is an instrument that connects to people. It can be any language. So I can talk so that's why, again, may not be very well, but again, I can talk English, Tamil, my mother tongue, Kannada. Hindi not very well, but yes, I have learned Hindi. I can, but probably if I have a neighbor who talks Hindi, I have the vocabulary. Hindi, I have the vocabulary, but I'm not used to talking. I'm not used to talking with anyone in Hindi. So probably if I have a neighbor who talks Hindi, 2-3 months I talk to that person, then yeah, I'll be good at Hindi. So I can talk Hindi. So it's nice now when you know. So there are people here who might know different languages, Malayalam, Telugu. It's nice. So Tamil is one such language. But then people abroad, they take pride in saying, no, our children don't know Tamil, they understand only English. So they're missing on something actually. You don't know a language and it happens to be your mother tongue. You don't know your mother tongue. One should feel ashamed to say that. You don't know, you cannot talk in your mother tongue, you must feel ashamed. But people take pride in saying that, because they're settled abroad, they feel it's okay not to know Tamil. So like that, memorizing is looked down upon. That's what I'm trying to say. Memorizing is looked down upon. Memorizing, no, I don't know, I can't memorize. Try to memorize. It's not easy to memorize. Memorizing is a skill. And you need to use that in studying. All right, children. So coming back to this. Yeah, this is about the theorem. And I can actually finish one more theorem we have, children. I can finish it if you can stay on for 10 minutes. Tell me honestly, how many of you have to leave? 10 minutes, one more theorem, and we are done with the introduction. We can jump into the exercise in the next class. Anybody has problem holding on for 10 more minutes? Please tell me now. Tanishka has to leave then. Ranjan has to leave. Okay. Anyone else? If majority of you can stay back, I would suggest people who have to leave now, I understand, may leave the call. You might have some other class or any other important task. So please, you may see majority of us are staying. Please let me know. Anybody else wants to leave? If majority of you are staying, I would like to continue for 10 more minutes. Okay, I don't see any more hands raised. So Tanishka and Shri Ranjan, you may leave the call if it is important to leave. I'll share the recording with you. Please watch the recording for the last 10 to 15 minutes. Okay, the last 10-15 minutes of the recording, please watch so that you can catch up with the class. Yeah, so the other theorem, children, is this one. The tangents, the lengths of the tangents drawn from an external point to the circle are equal. Oh, I didn't tell you about this. So how many tangents can be drawn to a circle? Okay, this again. When you're given a circle, children. Okay, I'm not talking about this theorem. Again, a general information. So when you're given a circle, okay, and a point lying inside the circle, you cannot draw a tangent to the circle. If you're given a circle and a point lying inside the circle, no tangent can be drawn. No tangent. You cannot draw a tangent passing through a point lying inside the circle. Now, supposing you're given a point lying on the circle, you can draw exactly one tangent passing through the tangent lying on the circle. If you're given a point lying outside the circle, you can draw exactly two tangents from that point lying outside the circle. It's a line, children. It's a line. See here. It goes on like this. It's a line. It's like that. Okay. So if you're given this point, outside the circle, you can draw exactly two tangents passing through this point outside the circle. Circle, a point lying inside the circle. Circle and a point A lying inside the circle. No tangent can be drawn. No tangent can be drawn through A. Can be drawn through A. No tangent can be drawn through A. A is a point lying inside the circle. You try to draw a tangent passing through A? No, you will not be successful. Circle, center O, point A lying on the circle. Exactly one tangent. Only one tangent can be drawn. Only one tangent can be drawn through this point A, which lies on the circle. Circle, center O, point A lying outside the circle. Exactly 2 tangents can be drawn. We'll change it. So see. Exactly 2 tangents, children. Exactly 2 tangents can be drawn passing through this point A, which lies outside the circle. 2 tangents can be drawn passing through this point A, which lies outside the circle. So this is about how many tangents can be drawn, how many tangents can be drawn through a given point lying inside the circle, no tangent. On the circle, exactly 1 tangent. Outside the circle, exactly 2 tangents. Now in this theorem, or the statement of this theorem goes like this: the lengths of the tangents drawn from an external point of the circle are equal. The lengths of the tangents. Now you will ask me, you said tangents are lines, then how can you measure their lengths? Line, so that's what it is. Certain terms you should understand the meaning according to the context. This is the correct statement. The statement is not incorrect. You need to understand the statement. The lengths of the tangents. So tangent is a line. It is not a line segment. Then how can you measure the length? It's a tangent segment. Okay, I'll show you the tangent segment. The lengths of the tangents drawn from an external point to the circle are equal. Okay. Circle, circle, external point. So circle, center O, external point A. What do you call this? This is the line segment joining the center and the external point. This is the line segment joining the center and the external point. And these are the tangents. 1 minute, children. This phone is disturbing me a lot. 1 second. CBSE 10 and 12 results are out, no? So I think my students are texting their marks. So, yeah. So circle, center O, point A lying outside the circle. OA is the line segment joining the center and the external point A. We know that 2 tangents can be drawn from A. A is an external point. 2 tangents can be drawn. One like this. One like this. Now they are lines, children. You can produce it. You can produce it. They are lines. Okay. So this is the point of contact. Say P. This is the point of contact. Say Q. Now join OP. Join OP. Radius. Join OQ. Radius. OQ radius. Join OP and OQ radius. Now we have to prove that AP is equal to AQ. What is AP? Tangent segment. Tangent segment. AP. A and P are points on the tangent. A and Q are points on the other tangent. So they are tangent segments. We need to prove that AP is equal to AQ. See, this is one tangent. This is the other tangent. Through the point A. Through the point A, these are the tangents. So A and P are points on one tangent. A and Q are the points on the other tangent. We have to prove that the tangent segments AP and AQ are equal. So for that, we use congruency in triangle AOP and triangle AOQ. In triangle AOP and triangle AOQ. Now we know that this is 90 degrees by the theorem. Tangent and radius perpendicular. This we know. Tangent and radius perpendicular. Okay, the radius, the tangent at any point of the circle is perpendicular to the radius through the point of contact. So this is 90 degrees by the theorem because this is the tangent, this is the radius through the point of contact, so 90 degrees. Here also, this is the radius, tangent, 90 degrees. That is where the radius and tangent meet. No, that's 90. Radius and tangent where they meet, it is 90 degrees. So this is 90. And then you know that this is R and this is also R, radius. This is angle 1, angle 2. And this happens to be the common side. This one happens to be the common side. So let's write this. Angle 1 of triangle AOP is equal to angle 2 of triangle AOQ because 90 degrees. So right angle. Hypotenuse OA is equal to the hypotenuse OA, common hypotenuse. Both are right triangles, so they have a common hypotenuse. Both the triangles are right triangles because angle 1 is 90, angle 2 is 90. Both the triangles are right triangles. So they have a common hypotenuse here. OA is equal to OA, common hypotenuse. So right angle hypotenuse. Now some other side. OP of the first triangle is equal to OQ of the second triangle because both radius of the same circle. OP radius, OQ radius. So by RHS congruence criterion, the two triangles are congruent to each other. CP-CTC, AP is equal to AQ. CP-CT, that is corresponding parts of congruent triangles are congruent. So AP is equal to AQ. So tangents, the lengths of the tangents drawn from an external point of the circle are equal. AP is equal to AQ. Am I clear, children?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
All of you? All of you? Understood everything of today's class, children? Please raise your hand because I didn't make you write at all. All right, thank you, children. Thank you. All right, children. So this was the introduction to the chapter circles. We are done with the introduction. So next session, we can dive into the exercise. So first I'll complete exercise, I think 10.1 and 10.2, I think they are. So I'll complete the exercises from NCERT and then we have a lot of, other numerical sums. We'll do them also. So first we'll complete NCERT and then we'll go to the extra problems. So this is about the introduction to the chapter circles. So I'll prepare the presentations. I'll prepare the presentation and I'll upload it in the library. Today there is no time to show. In tomorrow's class, I'll show you the library in the portal. So there you can see it. And then you can write out all the notes in your tuition classwork notebook. Okay. All right, children. So that's it for today's session. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you, ma'am.
Thank you, children.
Ma'am.
Yeah, I'll just stop the recording. 1 second.